everybody, ANALOGUE here. A bit of a different video for you this time. I'm actually going to introduce you to something that you may never have seen before. Let's have a look with this camera. No, it's not a Sinclair Spectrum. You've probably seen one of those. It's one of these. Let me just go to this camera and I can show you in a little bit more detail. This is the DCP Microdevelopments Interspec, and it's a bus expansion box that fits on the edge connector at the back of the Spectrum, and basically it allows you to have both analog and digital inputs and outputs. So we've got various ports on here. We've got an output port, we've got switch inputs for physical switches, we've got relay outputs, we've got 4 relays we can switch on and off, and on this side we've got an input port, digital, and then we've got an analog inputs for analog to digital conversion, so we can measure voltage changes between 0 and 2.7 volts. So it's quite a good unit, but it's not particularly well documented. It's not been documented as much as I can find on the web, and my original documentation when I bought this many moons ago, about 1984 possibly, I bought this, although inside it actually says 1983. It was the instructions that I've got mislaid. Now, I did a lot of searching on the internet and could find references to it, various magazines articles, and went onto websites, support groups and so on, and found various links to different bits and pieces, but couldn't find it specifically. But then I did come across the Southwest archive, computer archive, had a copy of it showing on their website. I contacted them and they very kindly scanned it and sent it to me. I then spent quite a few hours going through the documentation and OCR'd it and redrew the diagrams, etc., to produce my own manual for it, and I'll put a link to this on my website, my CL Electronics website. So what I'm going to do in this video is basically I'm going to go through this the original instructions that came with it, building these little circuits as like a test board so that we can check out and make sure that it is working. I have actually physically tested it with a couple of other connections and run a little bit of tests, and the relays click on and off, so I know that part of it is actually working. It's actually communicating with the Spectrum. So that's what I'm going to do. So I'll cut back to you when I've got various bits and pieces ready to connect to it, so I can show you it in operation. Right, I've made a little jig on a breadboard. I could never remember what this is called, breadboard. I've just got 4 push buttons for the time being. I've made a cable with 10 connectors for the input port. So on one side of the input port we've got a 0 volt line, we've got 5 volts on the other, and then the 8 inputs. I've only got 4 of them connected for the 4 switches. And according to the diagram that was supplied in the original instructions, you've got each of the input lines pulled up to the 5 volt line by a 4.7k resistor, and a push button which will take those lines back down to 0 when pressed. So that's the way I've got it wired up. And there's also a little Spectrum program for testing this, which I've put onto my computer, and I'll put it on the capture screen. Apologies for the colour, I'm not quite sure why it turns out as the background is yellow, but it does. It's a composite video into an AV to HDMI upscaler, and then in an HDMI capture. So that's basically the best way I can capture it at the moment, but it does work, so we can see what's happening. So if I run this now, we're left with a value showing up every time the cycle loops of 255. So that's showing that none of the buttons are pushed down. So as soon as we press the first one down, it changes to 247 and release it, and it drops back up to 255. The next button is 253, back up, then 251, then back up, and 254. So what we can do, we can obviously programmatically look for those values to determine which one of those buttons is pressed. So I think that's a pretty good test that that input port is working. I could test the other 4 inputs, but I'm pretty sure as one lot is working, the other lot is. All 8 input ports should be working okay. So the next thing is to check the output port, and I've got to build a little array of diodes to show that using the test program that is in the instructions. Right, I've now switched the connector that I made over to the output port, and I've wired it up as per the diagram in the manual, which I'll put a link to, which shows a diode coming from 5-volt rail through a 150 ohm resistor to the output port. So the output port is going to pull down the resistor and diode combination to turn on the diode. So there's the resistors, these are the output ports. The 0 isn't in use, it's just there for out of the way, so the 5 volts is there. I've got that put in the spectrum example that is in the manual, but I've added to it, because when you run this program all the LEDs stay on for a little while, and then to make sure that all the LEDs go off at the end, I've added that again, and after a little pause. So if we run this program, you should see the LEDs flicker, counting from 255 down to 0 in binary. There we go. Let's do that again. Good, eh? So that's that test done. The output port is definitely working. We know the input port's working. We've got the switches that we can now also use to test the mechanical input switch, and also the output we can test to control a relay. So I'll get set up for that and come back to you after that. Right, I've got the switches wired up to the 4 inputs as per the hardware example in the manual. We've got the 5 volts connected to there. So when I press one of the switches, we'll put each of the inputs up to 5 volts. I've typed in the example, which is basically to read the in63 port, and if I run that, it's giving a value already of minus 192, and the reason is that switches 1 to 4 are equivalent to D0 to D3 on the data bus, and so to read the true states of these inputs, the value from in63 should have 240 subtracted from it, because the data bus presumes D4 to D7 are all at a logical 1. Okay, if that makes sense, it should, but not 100% to me. Anyway, it does work because I've tested it before I started the video. So if I press the first switch there, we now get a value of 191. Release it, we go back up to 192. Press the next switch, we should get 190. And they're back up to 92 when I release it, then 188, and finally 184. So knowing these values, you can actually write your program, so when you look for that particular value, you know which switch has been pressed. Okay, next logical test is to check the relay output. So I need to hook up the relay outputs to connect. So when I press a switch, write a little program that will illuminate one of the LEDs when I press the switch. That's the next thing. I'll come back to you after I've done this. Okay, I've now connected up the relay outputs, and I've got the 4 outputs. There's only 4 relays in here to connect to these LED circuits, and using the common ground and positive from this to feed it. So when we turn the relay on, it will drop down the output of the resistor down to ground, and that should turn on the relay. And to do that, you use the command out 63, then a value, and the value should be either 1, 2, 4 or 8, depending on which of the relays, or a combination of those from 0 up to 15. Out 63, 0 will turn all the relays off, out 6315 will turn them all on, and if you turn on one relay and then change the value to turn on another relay, it will switch off the first one. So if you want to switch on relay 1 first and then relay 2, you need to enter out 63.3, which will switch on both relays. If you want to keep the first one switched on. A little bit complicated, but you'll get the picture. Right, what I've done is I've written a little program just to run through the combinations of this. So if we list that, you can see it there, and basically it's just a simple for next loop which will run through those values, and we'll see the numbers count up from 0 to 15 in binary on the LEDs when I run it, and then it will switch them off. So let's run that. There we go, nice and pretty, wasn't it? Let's do that again. There we are. So I'll include that listing in the write-up because it's not actually in this manual that I've rewritten. I may do another version of this manual to include that code in there. So that's the digital input and output ports, that's the relay drive and the switch inputs that we've covered. The last thing we need to cover is the analog to digital conversion. And to do that, I'm going to use the example in here where we use a couple of variable resistors to make a joystick. I've actually got a little joystick module which I've been planning to build a little joystick for ages, never got round to it, so it's an ideal opportunity to do that. I'll build it onto Veriboard so we can see it in operation, and then we can have a little Etch-a-Sketch and draw a little picture. Okay, see you after the break. Right, well it's the next day and I'm getting ready to make these joysticks for testing the analog to digital converter on the Interspec, and these are the joystick modules that I bought. Bought these on the web, I think through eBay, some time back with the intention of actually making a couple of joysticks. They are modules that are used for replacement of joysticks on keypads and things that are already made. They're not sort of like ones that you use to make yourself. So it's going to be a little bit of a do-it-yourself job to actually make this, but they do actually work quite well. So the joystick goes backwards and forwards in one direction, backwards and forwards the other, and it's also got a switch on it for a fire button like that, which we could employ. Now the layout of the pins on here doesn't quite match Veriboard. The three legs for the controls do, so both of those should be able to fit, but the actual mounting legs won't, so I'm going to have to do a little bit of bending and jiggering to get that in, but I've got enough Veriboard here spare to make two, so I'll make one to start with and then do the other one a bit later on, I expect. So I'm going to press on with that and then get that all set up so that from the instructions we can build this little control using these two pots. Now the two pots that are in here are actually 10k as opposed to 100k. So basically what that will do is, because we've got a 47k here, that will change the resistance of the input values into the two input ports 0 and 1. So we may have to vary that value of the 47k to make this a little bit more accurate. With a lower resistance, that's probably going to be highly movement. The movement is going to happen very, very quickly as opposed to slower. So I may have to increase that to 470k to make it up to what it was expecting with these. But we'll see. I'm going to build it with the 47k and see what it works and change that resistor if necessary. So I'll get on and build that, and then I'll cut back to that after I've got these built ready to test with the Interspec. Okay, so I've built the joystick onto a little bit of Veriboard and using a ribbon cable, because I plan to use this once I've got it working a little bit better with a game. Maybe not on this, maybe on the BBC. I might modify it for my BBC as well. But anyway, it's I've got it to a point where I can actually demonstrate it to you. So it's basically using the guide that we've got here in the book. We've got two inputs from 0 and 1 off the two wipers of the two pots here. Both pots are connected on the one side to the 0 rail, and on the other side through a resistor, 47k resistor to 5 volts. So that's all been put together, and I've even written the program that comes with it as a good little demo program. So let's list that. Now, one thing I did when I was doing this, I had a little play with it before I wanted to show you that it was working, and I found that it was a little bit difficult to see. So I've just changed one of the values on line 20 from y equals in 31 divided by 1.5. I changed it to just 0.5, and it just makes the range a little bit bigger so you can see it on this screen here. But 1.5 seems to work reasonably well, but it's the end result on the screen is just very small, and that's so you'll see that later on. So let's run that, and we can see just we've got some little dots there on the screen. And if I move the wipers, the pots on this are actually the wrong way round on one of them, the wiring. So, and it needs, this is what I say about needing a modification. The top of one needs to be replaced to the bottom of the other one because they don't work in the right direction. But if I move the joystick down, you can see it goes up. And if I move it up, you can see the line, the Etch-a-Sketch line that's produced goes down. If I move it to the right, so you'll actually see it go to the right, and left, it goes to the left. But if I move diagonally, you'll see it goes in the wrong way. But you can see the point is that it is actually working. So there is a proof of concept here more than anything that the analog input ports are working. So the analog to digital converter is working. Now obviously with time and a little bit of patience, you could probably make this into quite a good little program that would work, and it seems to be reasonably responsive, but obviously it's just a very basic test program that's in the manual. But I'm sure there's probably a game out there already that will do this, and this would probably work with it anyway. But the point is, we've now tested this port on the Interspec. We've now got the A to D side of it working. So we've tested all the inputs and the outputs. Yep, over on the Interspec we've tested the input port, we've tested the output port, we've tested the switch inputs, we've tested the relay drive, and we've tested the A to D converter. The only other thing that we ought to really test is the DCP bus, but unfortunately I don't have any other devices which I can connect this to at this point in time. Now I'm looking around to see if I can find any other DCP. There's a DCP speech module, and there's also a couple of other things, and there's information in here in this book about using that to connect to other devices. So if you have a look in page 8 in the manual, you'll see that there is ways to connect this through other devices for analog inputs and outputs through the expansion bus and so on. So there's quite a lot of information in there. As I said, you can download that as a PDF file from my website. It's not mine, it was written by David Palmer. So this is just my version of the manual that David Palmer produced. David Palmer, DCP, David Charlie Palmer, I don't know, Charles, Clive, whatever. Clive would be interesting. I don't know if he's still around, if he's still in the business, but anyway, thank you very much, Mr. Palmer, for creating the Interspec and various other devices. It's been interesting to see this. Hope you've enjoyed this little look into the Interspec. I hope to get some of my old Meccano models out and reconnected to this device as I used to use years ago to control it, and see if I can find the programs that control that as well, so I can just give you a bit more of a demonstration of how well it works. Anyway, thanks very much for watching. See you very soon. Bye bye.